Hello students, today we will be continuing our chapter number 2 that is intersection of solids. In the previous lectures, we have solved problem based on intersection of cylinder, intersection of cylinder and a prism, as well as we have solved problem based on intersection of prism and prism. In case of intersection of prism and prism, we have solved problem in which it was given that the axes of both the prisms are bisecting each other at right angles. Today we will be solving intersection of prism and prism in which the axes will be at right angles to each other, but they will not be bisecting each other. That is, the axis of one of the solid will be offset from the other axis. Now let's begin with the problem. So problem number 4. A vertical square prism of side of base 50 mm and axis length 100 mm has its vertical faces equally inclined to HP. So in the question it is given that the object, which is a vertical square prism, has a dimension as 50 mm of side of the base and its height is 100 mm, as well as it is having its vertical faces equally inclined to HP. Since the vertical faces are equally inclined to the VP, when we will draw the top view of the vertical square prism, we will draw a square in the form of a kite with its side equal to 50 mm. Now the vertical square prism will have its top view as a square, whereas the front view and the side view will be rectangles. Now in the second statement it is given, it is penetrated, that is it is intersected by another square prism. So the horizontal object is a square prism with side of base again 50 mm and axis length 100 mm. So the dimensions of both the horizontal and vertical square prisms are same, that is both are having side of base as 50 mm and the height is 100 mm. So that its axis is parallel to HP and VP and 12 mm in front of the axis of vertical prism. Now here the axis of the horizontal square prism is 12 mm in front of the axis of the vertical prism. It means the axes are not bisecting each other. They are offset at a distance of 12 mm with respect to each other. The faces of the penetrating prism are equally inclined to HP. Now since it is given that the faces of the penetrating prism, that is the horizontal square prism, are equally inclined to HP, when we will draw the side view of the horizontal square prism, it will be a square of side 50 mm but in the form of a kite. So for drawing the horizontal square prism, first we have to project the side view, and then from the side view we will project the top view and the front view. And finally, after drawing the front view, top view and side view of both the prisms, we will mark the points of intersection. And then by using the points of intersection, we will draw the lines of intersection where the surfaces of both the prisms will intersect each other. So let's begin with the solution. So intersection of prism and prism, offset condition. Now first step, we have to draw the top view of the vertical square prism. Now top view will be nothing, a square will be a square in the form of kite with dimension as 50 mm. So we will draw the top view first. So this is the top view of the vertical square prism of side 50 mm. So we will give the dimensions of 50 mm. Now we will mark the corners of the square 1, 2, 3 and 4. Now these corner points, that is 1, 2, 3 and 4, are nothing but the top view of the vertical edges of the vertical square prism. Now after drawing the top view, now we will project the front view and side view. So first we will draw the XY line. Now we will project the points 1, 2, 3 and 4 one by one on the XY line. So we have projected point 1 on the XY line. Now we will project point 2 and 4 on XY line, and similarly we will project the point 3 on XY line. Now point 2 and 4 are lying in a straight line. So the line of projection for 2 and 4 will be single line, it is this line. And the last point projected will be point number 3. Now we will complete the front view of the vertical square prism. Now the front view will be nothing but a rectangle. Now you can see here that this vertical square prism will have four rectangular surfaces, that is 1 to 2, 2 to 3, 3 to 4 and 4 to 1. These all sides represent the lateral surface of the vertical square prism, which will be nothing but rectangular surfaces. Now if we observe this square in the front view direction, you can see faces 1 to 2 and 2 to 3 are visible. So we have to draw two rectangles in the front view since these two faces are visible. So the front view will be a rectangle of height 100 mm since In the question it is given that the axis of the vertical square prism is of height 100 mm. So we have projected the front view with height as 100 mm. Now we have marked the points which represent the edges. 1 to m will represent the edge 1. Similarly 2, 2 and 4, 4 will represent the second edge, and 3 to 3 will represent the third edge. Now we have not drawn here the edge number 2 to 2 and 4 to 4. We will draw these edges later on. Also you can see that the some part of the vertical edge 1 1 and 3 3 are kept as light, that is they are not drawn, or they are drawn with the help of faint line. This is because this part will not exist. We will understand this later on when we will proceed further completing the problem. For now, you have to draw the front view as a rectangle with height 100 mm and then mark the vertical edges 1, 2, 3, 4. Now we will project the side view. In order to draw the side view, you have to draw first a line inclined at 45 degree to the XY line. So we have drawn the XY line inclined at 45 degree. Now we will project all these points, that is 1, 2, 3 and 4 on the XY line one by one. So we have projected all these points on the XY line on the 45-degree line. Now we will project, or we will draw vertical projection lines from all these points in the side view so that we can complete the side view. So now we have projected the lines on the XY line in the side view. Now in order to draw the side view of the vertical square prism, first we have to project the height of the vertical square prism. So we will project the height equal to 100 mm from the front view into the side view. So we have projected the height directly. Now we will complete the vertical edges, or we will complete the left hand side view. So we have drawn the left hand side view, which will be again a rectangle. Now you can observe that if we observe this square from this view or from this side, you can observe two rectangular faces are visible. That is face 1 to 2 and 1 to 4. So we can say that the side view of this vertical square prism will consist of two rectangles. That is rectangular face represented by side 4 to 1 and rectangular face represented by side 1 to 2. So you have to draw a rectangle in the side view. Now this portion is kept as light. The reason will be explained later on. Now we will mark the edges. So first we have marked the edge 4, 4 to 4. Then we will mark the edges 1 and 3. So we have projected 1 and 3 here. So edge 1 to 1 and edge 3 to 3. And the last is edge number 2. So edge 2 and 2. So we have completed the front view, top view and side view of the vertical square prism. Now please note that some of the edges in the front view as well as side view have not been drawn. This will be drawn later on when we will proceed further. Now we will proceed towards drawing the side view of the horizontal square prism. Now the side view of the horizontal square prism will be a square in the form of a kite. In order to draw the square, first we have to mark the center of the square in the side view. So to mark the center of the square, first we have to take a distance of 50 mm from the base. That is, from XY line, take a distance of 50 mm from the XY line and draw a light projection line. Now we will draw the edge 1 to 1 and 3 to 3. This is the edge of the vertical square prism. This part should be kept as light. Now we have obtained this point, that is the intersection of the vertical edge 1 1 and the horizontal projection line at a distance of 50 mm. In the previous sum, we have marked this point, that is the intersection of the vertical edge and this horizontal line, as the axis of the horizontal square prism. But in this case, this point, that is the point of intersection of this line and this vertical line, will not be the intersection point or will not be the axis of the horizontal square prism. In order to mark the axis, we have to take a distance of 12 mm in front of. Now it was given in the question that the axis of the horizontal square prism is 12 mm in front of axis of the vertical prism. Now it is clear that the axis of the vertical square prism will be lying on this line. If we mark the axis or the center of the square, it will be lying on this line itself. So if we project the axis of this vertical square prism, it will be coinciding with edge 1 1 and 3 3. So in short we can say that the axis is lying on this line itself, that is 1 to 1 and 3 to 3. Now in the question, since it is given that the axis of the horizontal square prism is 12 mm in front of axis of the vertical square prism, so we have to take a distance of 12 mm from the axis of the vertical square prism. So we will take a distance of 12 mm from this line, and in front of means we will take the distance here to here. You can see how we can mark the distance. So I have taken a distance of 12 mm from here to here and draw a light projection vertical line at a distance of 12 mm. So now this point, that is the point of intersection of this light projection line and this vertical line, that is this point, will represent the axis of the horizontal square prism, since it is satisfying the condition of 12 mm offset. Now we will draw the horizontal square prism in the form of a kite. So we have drawn the horizontal square prism. Now the dimension will be marked. We have marked the corners as A, B, C and D, and the dimension is 50 mm. So students, keep in mind that whenever the offset condition is given, you should not mark the axis of the horizontal square prism directly at this point, that is intersection of 1 1 and this horizontal light line, but the axis should be marked at a point by taking the offset distance, that is 12 mm here. So we have taken a distance of 12 mm from this point to this point, and then this point, that is the intersection of this line and the horizontal light line at a distance of 50 mm, will be marked as point of or the axis of the horizontal square prism. So this is the axis of the horizontal square prism, and the side is equal to 50 mm. We have also marked the corners as A, B, C and D. Now you can see that some part of this vertical projection line, that is 1 1 and 3 3, or we can say that the edge 1 to 1 and 3 to 3 is kept as light, that is this portion from here to here, as well as the portion of this edge from here to here is kept as light. Now the reason is that if we want to insert or we are to intersect this horizontal square prism inside this vertical square prism, while inserting, this portion of the edges will be removed. If we do not remove this edge, then the horizontal square prism cannot be inserted inside the vertical square prism. So this portion of the edge 1 to 1 and 3 to 3 is not existing. So we have kept this portion from here to here as light. Similarly, this portion of edge 2 from here to here is also not existing. So this portion has to be kept as light. Whereas the remaining portion lying outside the horizontal square prism, that is here to here and here to here, is to be kept as dark. Now we have completed the side view of the horizontal square prism. Now we will project the top view and the front view of the horizontal square prism one by one. For projecting the top view, we have to project the points A, B, C and D on this 45-degree line. So we will project the points. So we have projected point D on 45-degree line. We have projected point A and C on 45-degree line, and we have projected point B on 45-degree line. Now we will project the top view. So after projecting point D, we have projected in the top view. Similarly, we have projected point A and C in the top view, and we have projected point B in the top view. Now the length of this line will be equal to 100 mm. Okay, we will project. So we have projected the lines, and in the top view we have completed the rectangle. Now you can see here that from the top view, when we observe this horizontal square prism, its two rectangular faces will be visible, that is face A to B and A to D. It is two rectangular faces will be visible. So in short, we can say that from the top view, two rectangles will be visible. So this is the first rectangle and this is the second rectangle. Now you can see that the portion of this edge, some portion of this edge is going inside the vertical square prism. Similarly, some portion of this edge is going inside the vertical square prism. So the portion of the horizontal square prism which is lying inside the vertical square prism will be not visible from the top view, or we can say it is hidden. So while drawing the edges, we have to draw hidden lines to represent the part of the edge that is lying inside the vertical square prism, and this length will be equal to 100 mm. Since in the question it was given that the length or the axis of the horizontal prism is also equal to the 100 mm. So in order to draw this line, first you have to mark the center, and from this center, that is take the center of line 1 to 3, and from this center of line 1 to 3 take distance of 50 mm towards left and 50 mm towards right. So the total distance will be equal to 100 mm. Now we will complete the hidden portion. Now you can see this post part of the edge of this edge is going inside the vertical square prism, so it will be hidden. Similarly, this part of the edge will be lying inside the vertical square prism, so this will be hidden. So these two edges are hidden, so as they are lying inside the vertical square prism. Now we will draw the front view. To draw the front view of the horizontal square prism, just project the points A, B, C and D in the front view from the side view. Similarly, project the length from the top view into the front view. So we have projected the points in the side view, in the front view from the side view, and we have projected the length equal to 100 mm from the top view into the front view. So this is nothing but the portion represented in the green line is nothing but the front view of the horizontal square prism. Now you can see that this portion from here to here is not drawn. Similarly, the portion from here to here is not drawn. We will draw this later on. Now this edge is nothing but the edge B to B. Now if we observe this horizontal square prism from the right hand side view, we can see two faces, that is face A to B and B to C. So from the side view, two faces or two rectangular faces A, B and B to C are visible. So we have to draw two rectangles in the front view. Also HB is not intersecting the vertical square prism, or we can say that this HB is not cut by the vertical square prism. So we have completely drawn the HB. This line represents nothing but the edge passing through the point B, as this is a projection of B and D. Now we have drawn the horizontal edges of the horizontal square prism. So first is edge A to A, second is B to B and D to D, and the third is C to C. So we have drawn all the edges, that is A, B, C and D in the front view. Now in the next step we will mark the points of intersection. Now you can see we have already marked 4 points A, B, C and D. Now we have to mark the remaining points of intersection where the horizontal square prism will cut the vertical square prism. Now you can see this side is cutting the vertical edge at 2 points, that is W and X. So we have to mark 2 points W and X, that is the points of intersection. Similarly, this vertical edge, that is 1 1 and 3 3, is cut by the horizontal square prism at 2 points, one on the upper side named as point number Z and one on the lower side named as point number Y. So we have marked 4 extra points of intersection, that is W, X, Y and Z. So you have to remember this step that we have to always mark corner points as well as the points where the sides of the horizontal prism are intersecting the edges of the vertical prism. So here side A to B is intersecting the S2 at W, and side C to B is intersecting the S2 at X. Similarly, side A to D is intersecting the vertical edge 1 and 3 at Z, and side D to C is intersecting the vertical edge 1 and 3 at Y. So these are the 4 points of intersection, W and X and Y and Z. Now we will mark these points of intersection in the top view also. So you can see first we have projected point W and X in the top view. Now W and X are lying on the vertical edge 2 itself. So on point 2 itself we have to mark points W and X since they are lying on vertical edge 2 itself. Now the next point to be marked are point A and C. Now students, we don't have to mark point B since this point B is not intersecting with the vertical square prism anywhere. All the intersection points are starting from W and ending at X. This point will not intersect. So we have already marked point W and X. Now we will mark point A and C. So after projecting this point, this edge cuts the vertical square prism on left hand side as well as on right hand side. So we have to mark point A and C on left side also and on right side also. On left side we have used this letter P, PA and PC to represent point A and C. And on the right side we have marked the intersection point as QA and QC. Now the next point to be marked is point Z and point Y. Now you can see Z and Y are lying on vertical edge 1 and 3 itself. So we have to mark this Z and Y on 1 and on 3 also. So we mark the point PY and PZ on left hand side and QY on QZ on right hand side. You have to mark these points, that is A to C, Z and Y on both left side and right side. WNX was marked only on point 2, as for this point no left hand side and no right hand side exists, but for these edges both left hand side and right hand side exist. So we have to mark point on the left also and on the right also. On the left use the letter P for representing the points, and on the right use the letter Q for representing the points. Now the last point of intersection we mark is point number D. Now we have projected this point number D, and this is the HD. So this line represents the HD. So wherever this H cuts the vertical square prism, that is this point and this point, will be marked as point of intersection, that is PD and QD. So we have marked the next point of intersection PD and QD. PD on left and QD on right. So finally we have marked all the points of intersection beginning from W, A, Z, D, Y, C and X. Point B is not intersecting anywhere, so we don't have to mark this point B anywhere in the top view. So these are my points of intersection, or these are the points where the edges of the horizontal square prism will cut the faces or the rectangular faces of the vertical square prism. Now, why we are marking these points of intersection? These points of intersection are used to draw the lines of intersection in the front view. As in the question it was given, we have to draw what? Lines of intersection. So, in order to draw the lines of intersection, we have to mark the points of intersection first in the side view and then project the points of intersection in the top view. And finally, now we will project these points of intersection or all these points in the front view one by one. Now we will start projecting. So first we have drawn the edge 2 and 2 and 4 and 4. Now you can see that only this portion of edge 2 and 4 is drawn. It is from here to here, and from here to here is dark, whereas this portion is light. The reason is that, as you can see from the side view, the portion of the edge 2 and 2 lying inside the horizontal square prism will be removed. Since we have inserted this horizontal square prism inside the vertical square portion, this portion of the S22 will not exist in reality, or we can say this portion has been removed due to insertion of the horizontal prism inside the vertical prism. So we have to keep this portion from here to here as light, as this part is not existing, whereas the remaining part, that is from 2 to W and 2 to X, are existing. So we have drawn 2 to X dark and 2 to W also dark. Now we will project the points of intersection. Now we have projected first point, that is W and X. We have projected W in the front view by drawing horizontal projection line. Similarly, we have projected point X in the front view by drawing horizontal projection line. Now we will mark this point W and X in the front view. Now you can see W is lying on this horizontal projection line, and from the top view, if we draw vertical projection line, we can see point W is lying on this line. So wherever this vertical projection line cuts this horizontal projection line representing point W, that will be marked as point at W. So we have marked point W. Similarly, point X will be lying on this horizontal line. So wherever this vertical line representing point X will cut the horizontal line, that will be marked as point number X. So point number W and point number X have been marked in the front view. Similarly, we will mark the point PA, PC, QA, QC. PY, PZ, QY, QZ, and PD and QD. In order to mark the points of intersection in the front view, just we have to draw horizontal projection lines from the side view into the front view, and we have to draw vertical projection lines from these points into the front view. and wherever these vertical projection lines will cut these horizontal projection lines, that will be marked as points of intersection. Now the next point we mark is point PA and PC, QA and QC. So we have drawn vertical projection line, that is this line passing through PA and PC, and another vertical projection line passing through QA and QC, that is this. This is the line or the vertical projection line passing through point QA and QC. So we can say that point QA and point QC will lie on this vertical line, whereas point PA and PC will lie on this vertical projection line. Now we have to project point A and C from the side view also. Or we can say we have to draw horizontal lines from point A into the front view and from point C into the front view. We will draw the horizontal projection line. So we can see here that we have projected the point A in the front view by drawing the horizontal projection line. Now PA is drawn from this vertical projection line. So wherever this vertical projection line cuts this line, that will be marked as point PA, and on the right hand side we have to mark similar point QA. Now you can see that the portion from PA to QA is drawn as hidden. The reason is that you can see from the top view that from here to here, that is the portion of the edge A and C going inside the vertical square prism will be hidden, or it will not be visible. So when we have projected this distance in the front view, it will be shown as a hidden line. Now we will mark the next point, that is point number C. We have marked A on upper side, PA and QA. Now we will mark PC and QC in the front view. Similarly, we have to draw horizontal projection line from point C into the front view, and then vertical projection line is already drawn. So we will mark the points. Now you can see we have projected the point C in the front view. Again, the portion of this edge C from here to here, we can say from PC to QC, is hidden. The reason is same. This portion from PC to QC is inside the vertical square prism, so it will not be visible. So this portion will be hidden, whereas the remaining part lying outside will be visible. And we have marked point PC and QC. Now the next point we marked as PY and PZ and QY and QZ. So we have already drawn the vertical projection line passing through PY and PZ and the vertical projection line passing through QY and QZ. Now we have to simply draw horizontal projection line passing through Z. That is, we have to draw horizontal projection line in the front view from Z and horizontal projection line in the front view passing through point Y. So we will draw the lines. So we have drawn the line passing through Z. Now we will draw the line passing through Y. After drawing the line passing through the Z, we have marked point PZ and QZ. You can see this is the line representing the point Z. So intersection of this horizontal line passing through Z and this vertical line passing through Z will be marked as PZ, and on the right hand side we will mark point QZ. Now the next point we mark is PY and QY. So we will project this point Y in the front view. We have projected the point Y in the front view. Now we will mark point PY. Now you can see PY will be lying on this line. So wherever this horizontal line intersects this vertical projection line, that will be marked as point PY. So Py on the left side and Qy on the right side. Now the last point of intersection to be marked is point D. So we have already projected the point D in the front view. So this S represents what? Point D, or the edge passing through D. Now we will draw vertical projection line passing through point PD and QD in the front view, so that we can mark the point D. So first we have drawn vertical projection line passing through PD. Now we will draw vertical projection line passing through QD. We have drawn the lines. Now wherever this vertical line passing through PD intersects this line, that will be marked as point D. So this point will be marked as PD, and this point will be marked as QD. So finally we have marked all the points of intersection, that is PA, PZ, PD, PY, PC and W and X. Now we have to join these points of intersection in proper sequence so that we can draw the lines of intersection which was asked in the question. In order to join the points, you have to follow the sequence. Now you can see from the right hand side view, points W and A are visible. If you see this square prism from the right hand side view, only points A, W, B are visible and points C, X and B are visible. Whereas these points, that is A, Z, D, Y and C, are not visible from the right hand side view. So when we will join the points A to W and C to X, they will be dark joined with the help of dark line as they are visible. Whereas when we will join the points a to Z, Z to D, D to Y, and Y to C. They will be joined with the help of dotted lines or hidden lines since they are not visible from the side view. So, in order to identify which line will be dark or which line will be hidden, you have to just observe the prism from the right hand side view, and the portion which is visible from the right hand side view or the points which are visible from the right hand side view, they will be joined with the help of a dark line, and the points which are not visible, they will be joined with the help of a hidden line or dotted line. And point B is not intersecting, so we have not marked point B anywhere. So we have to first join point W to A and X to C with the help of dark line. So we will join W to A, W to A. Since A is marked on both sides, we have to join both the lines, W to PA, W to QA, and next X to X to PC, X to PC, and X to QC. We will draw the lines. So W to PA, W to QA, X to PC, and X to QC. All these four lines are dark because this part W to A and X to C, or these points are visible from the right hand side view. Now while joining these points, all the lines will be hidden since they are not visible from the right hand side view. Now next we will join A to Z. So PA to PZ hidden. Next will be Z to D, which will again be hidden. So Z to D hidden. Now we will join D to Y, which will again be hidden. So D to Y hidden, and the last is Y to C, which will again be hidden. So we have completed the intersection on the left hand side. Now again we will join the points in the same sequence, that is A to Z, Z to D. So A to Z hidden, Z to D again hidden, D to Y again hidden, and Y to C again hidden. So finally we have completed the lines of intersection. Now the last portion remaining in this problem is that we have to complete these edges, that is edge 1 to 1, 2 to 4, 3 to 3. Now, as already explained, the portion of the H2 to 2 and 4, that is H2 and H4, from here to here will not exist. You can see that this portion from W to X is not existing since this part is removed or this edge is removed due to the insertion of the horizontal square prism. So the edge will not exist here. So we have to draw nothing but light line from W to X. Only this portion will exist. Now for edge 1 and 3 we have to observe it. For edge 1 you can see edge 1 and 3, for edge 1 and 3 portion from here to here is existing, and also from here to here is existing, but the portion from Z to Y is not existing. So for from Z to Y we have to draw faint line because this portion of the edge 1 is not existing. Similarly, portion of the edge 3 from Z to Y is not existing, so we have to keep it as a light line. But the edge 1 to Z is existing. We can see 1 to Z is existing, 3 to Z is also existing, 1 to Y is existing, and 3 to Y is also existing. But you can see in the front view, we have already drawn this portion of 1 to Z, whereas this portion is remaining, that is from here to point Z. Similarly, on the bottom side, we can see we have drawn the portion of the H1 from here to here, but this portion is remaining. So we have completed this remaining part, that is this line, this line. Now from the side view, you can see that when we observe this edge, only the portion from here, that is this point to this point, will be visible from the right hand side view. From the right hand side view, the portion of the edge 1 and 3 from here to here will be visible, but this portion from here to here will not be visible since it is lying on the back side of this side, that is A to D. So this portion from here to here will not be visible. Similarly for the lower part, only this or the portion from 1 to C, that is this portion, will be visible, whereas this portion from Y to C will not be visible. So we have to draw hidden lines from here to Z point. Similarly, we have to draw hidden line from this point to Y point. On the right hand side also we have to draw hidden line from this point to QZ, and on the bottom side you have to draw hidden line from this point to QY. So basically this portion, this 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 and this will be drawn with the help of hidden lines. So you can see this portion is hidden, this portion is hidden, this portion is hidden, and this portion is hidden, because the portion of the edge 1 and 3 from here to here will not be visible from the right hand side view. Only this portion from here to here will be visible. Similarly, on the top view, the portion of the edge 1 and 3 from here to here will be visible. But the lower portion from here to here will not be visible, since it is covered by this face of A to D and D to C. So only the upper part will be dark from here to here, whereas the lower portion will be dotted. So finally, we have completed a numerical. We have completed the front view, top view, and side view of both the horizontal and square vertical square prism. We have drawn the lines of intersection also.